Okay, welcome to lecture number 2 in our series of modules on produce food safety, which is targeted towards undergraduate students. Today, we're going to learn a little bit more how industry and government agencies handle foodborne illness outbreaks in order to help you prepare to be on either side of that equation when something like that, when an outbreak happens. As part of this, you will understand sources and transmission pathways of Listeria monocytogenes and hepatitis A in produce. And what you learned is not just applicable to those two organisms. The same issues, the same transmission pathways may happen with other pathogens. And in the bigger picture, you're going to learn a little bit more how to analyze food safety issues. And we'll achieve that by having me joined by Jonathan and Yadi, two of our students at Cornell. And we will ask questions throughout, check in for understanding, etc., so that you can better see how people will look at this and these issues that I'm going to present today. So the first issue we're going to talk about is the Listeria outbreak. This is a real outbreak that happened, but we're going to go not just through what happened there, but how we might have gotten to the conclusions, what other conclusions could have been reached, etc., to make it not as black and as white as it may look, because often these outbreaks aren't black and white. So this outbreak happened January to August 2010, 10 listeriosis cases, 5 hospitals in Texas. And all the patients were all the people with listeriosis were either patients or visitors at these hospitals throughout the 7-month period. CDC investigated this outbreak, as they usually do. And in Hospital A, they found a strain of Listeria that matched the patient strains, or what we call the outbreak strain, to an isolate that was obtained from chicken salad that was prepared at the hospital kitchen. So on the right side here, you see what we sort of call a different forms of the epi curve. It shows when the date of the Listeria specimen was collected. So when a sample was collected from a patient. And so you can see, the first sample was collected sort of early January 2010, and the last one was collected what looks like middle of August of 2010. And then it shows you which hospital people were in and when they were at the hospital. And then the diamond here indicates what they call the start of the possible incubation period. And so you can see all of these patients within the incubation period were in one hospital or another. And, guys, Jonathan, Yadi, if you were a CDC, which hospital would you look at first and why, looking at this curve?
I would say that we will go with Hospital A because they have the first case, and then overall throughout the epi curve also, we see availability of cases at Hospital A the most.
Right. So you really see out of all the cases, 6 of them or 5 of them, 6 of them, I guess, were all at Hospital A at some point, right? This one was, 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 this one was. The other ones are sort of single cases, There's 1 in C, 1 in D, etc. So A is definitely the main hospital responsible for this. So that's why you would start there, right? So that all makes sense with regard to an investigation. So let's talk a little bit about Listeria before we dive in deeper. So one thing you need to know about Listeria is it's a common organism. You find it in soil, you find it in water, you find it in processing plants. We and others have done studies where if you go to a city, New York City, wherever you want to go and collect samples from sidewalks, playgrounds, parks, etc., you can find 5% of these samples positive for Listeria monocytogenes. It's well known for the fact that it grows at refrigeration temperatures, so refrigerated foods are an issue because you will get more Listeria the longer it's stored, and the more Listeria you have, the higher likelihood of illness. Outbreaks have been associated with a number of different foods: meat, cheese, milk, non-pasteurized and pasteurized, fresh produce, really a variety of different types of products. What makes it different from some other foodborne diseases is that it has a long incubation period. E. coli, salmonella usually get sick 2 to 3 days after you consume a contaminated food. Listeria, that can be up to 60 days. 90 days will be long, but 60 days will be the typical one. The other important thing about Listeria is that it causes a very severe disease. It's not your stereotypical foodborne illness with vomiting and diarrhea. Here we're talking about blood poisoning, septicemia, abortions in pregnant women, and brain infections. So severe brain infections, so severe that 90% of people with listeriosis end up in the hospital, and about 20% of people die. Now, the other intriguing thing is, and then this might sound counterintuitive, is that we have 1,600 cases a year, which is not that many, but we have it to be found it very commonly. 5% of samples in a city, frequently found in processing plants, not unusual to find in food, compared it to 1 million salmonella cases. How could you have a pathogen that's so common, found in so many places, yet so comparatively few people, 1,600 out of 330 million in the US, get sick? What does that tell you about this organism?
It's only effective on people who are somewhat immunocompromised.
So one explanation would be most people eat it, consume it, get exposed to it, don't get sick because they don't have a weakened immune system, right? Any other explanation or additional explanations? Because some of the estimates is that 20–30% of people in the US are immunocompromised. So 1,600 is still a pretty small number.
Another thing could be people get it and they just don't get sick enough that it's reported.
Yeah, that's one. And that doesn't seem to be the case based on all the data. What else could it mean? What it means with Listeria, and it's pretty well established, is that you need very high numbers of the organism to get sick. If you ingest 10, 100, 1,000, huge chance that you're not getting sick. Essentially, no one gets sick with ingesting 1,000 Listeria. One of the estimates is that if you ingest 1 billion Listeria, that's a lot, 1 billion Listeria in a single meal, and you're a pregnant woman, your chance of disease is 1 in 500. And that's really, really important practically for food industry, because even if product is contaminated, as long as it's refrigerated properly, because Listeria grows at refrigeration temperature, but the lower the temperature, the slower it grows. As long as you have practices in place to prevent it from growing to high levels, you're not going to see many cases because it requires such high levels, and high levels of the billion range you're only going to get if the organism grows after contamination. So, all right. So now here we are. So we have this outbreak scenario. Give you a little bit of background information. So listeriosis outbreak, 10 patients, 5 hospitals. They found it in a chicken salad prepared in a hospital kitchen of Hospital A. What do you think is going to happen next? What's CDC, what's FDA going to do? What's the hospital going to do? Just not feed chicken salad to people anymore? Stop doing that? Or what's going to happen here?
I have a clarifying question. So they only have one match with these cases?
So all the cases, because that outbreak is, all these cases are caused by very similar, or what we're going to call almost identical Listeria. So they're the same fingerprint, all 10 human cases, and the one isolate from chicken salad in Hospital A. So essentially think of them as all the same. 10 people, 1 chicken salad.
So okay, so they've all of these organisms have been isolated and sequenced, and okay, they all match the patient. All right.
Yep.
Or the salad.
Well, they all match. They all match each other, and they all match the salad exactly.
That to me would seem as though maybe a supplier could be a common source of this Listeria isolate.
Supplier of what?
If the chicken salad is pre-prepared, it could be the salad itself. If for whatever
the chicken
reason,
salad is prepared in the hospital kitchen, and I failed to point it out. So it's prepared in the hospital kitchen. So they take components and put it together.
Yeah, so that becomes more difficult because then you have multiple ingredients going into that chicken salad.
Yeah. So the other thing in the fine print here, they already done some testing. They couldn't find it in diced chicken that was used, nor could they find it in any environmental specimens. So the suspicions here often is like, well, and we've seen outbreaks like this where the Listeria actually lives in the hospital kitchen. It's a slicer that's contaminated over time, and that contaminates deli meats, and that makes people sick. Been there, done that, that's been it. So they didn't find it in the environment. They didn't find it in the diced chicken. So now what?
Just one more clarifying question, sorry. So all of these hospitals, like for the purposes of this, are separately owned and they all source raw ingredients to make this. There's no like common like kitchen that supplies these different hospitals.
Really good question. And this outbreak investigation didn't talk about that, but that's definitely something someone would look at. So I think what you're implying, Jonathan, is like, hold on, we got some hospital E, we got some hospital C, we got some hospital B. Can we look whether they're A, are they all doing chicken salad? And if so, is there one ingredient of the chicken salad that goes to all hospitals, right? Is that what you're after? Saying if each
That wasn't
hospital,
exactly what I was asking. It was more like if hospital A and B are owned by, the same big company and both happen to be the food service happens to be provided by some catering company, let's say. Maybe that catering company has a common kitchen that they do stuff, and then
could look
maybe
into the catering company. That definitely happens. But again, the salad was actually prepped at the hospital kitchen. But I think it's a good point. It's something definitely the type of question FDA would ask or CDC would ask is common supplier, common, what they often call a commissary, or maybe even one hospital makes the chicken salad or they're shipping it to other ones if they commonly owned, which would be unusual, but more unusual things have happened. Okay, what else are we gonna do? So we're gonna ask all these questions. What else? Let's go for the obvious one. It's prepared in the kitchen of the hospital, right? And you guys already sort of went there a little bit. It's prepared in the kitchen, didn't find it in the environment, didn't find it in the chicken.
Oh, yeah, then it has to be some of the other ingredients.
Right. We're gonna look at the ingredients, and here are our ingredients. Okay, this is what else we have. What do you think? What's our high risk ingredient here? Which one do we think is the Listeria coming from?
Celery or onion?
Okay, celery or onion. I think there was an outbreak linked to hard-boiled eggs in Listeria. There was some weird stuff happening with it recently, but yes. So I'll probably exclude the mustard and the salt, not necessarily completely, because it could come in, and then once you move it into the chicken salad, it could grow in the chicken salad. Now, the chicken, they said they tested an unopened bag and didn't find it. Would you think that's sufficient? One unopened bag didn't find it means it's not the chicken?
No, that didn't rule out the chicken if like the bag they used was unopened.
Right. Well, unopened, yeah. So even a chicken, if it's a chicken, it could be one bag is positive, another bag is negative, right? Typically, contamination at this level isn't like all bags are contaminated or no bags are contaminated. Often it's like 5% of bags. So definitely we want to do some more testing of the chicken because that is, would be sort of the stereotypical most likely source. But then you're probably going to test the celery. Would you completely stay away from testing pickles, mayonnaise, mustard, and salt, or would you do sort of what we call a risk-based sampling? What would you do?
Pickles, I would think, are somewhat less likely, mostly because they're acidified. I mean, the salt wouldn't really matter for Listeria. Mayonnaise, low water activity.
Right, but the trick is one of them could introduce it in the chicken salad, right? So if I bring in the Listeria with the mayonnaise, it could survive. I put it in a chicken salad, mix it up. Now the chicken salad overall, or at least some components of it, might support growth. Now if my hospital refrigerator runs at 45 degrees Fahrenheit, and I'm storing the chicken salad there for 2 days, I'm gonna run into a problem. I give it to a person, they don't eat the chicken salad, but they hide it in their drawers and say, oh, chicken salad for lunch. I'm not hungry anymore. Let's keep it for dinner. Oops, I forgot it. Let's eat it for breakfast. Suddenly a chicken salad sits around for 12 hours, allowing Listeria to grow, right? And weirder things have happened in hospitals. So just because the ingredient doesn't allow growth wouldn't mean I would exclude it, okay? Because of these ingredients, do you think celery is allowing growth?
Not exactly. I mean, celery is pretty low nutrients compared to like chicken.
Yeah, chicken will be the big one. Celery may or may not, I'm not sure. But we're on the right track. So we're gonna look at the ingredients. We're either gonna test as much as we can from each of them or do some risk-based to test a lot more chicken, celery, onions, maybe less of the pickles, the mayo, the eggs, and maybe even less of salt and mustard. Go ahead.
Do they buy raw eggs and then boil them themselves? And same
These
with
were
the
pre-boiled. These were pre-boiled, and the chicken was pre-cooked.
Pre-cooked. Okay.
Yeah. Yeah. And so it comes in a bag of pre-cooked chicken. Why are you asking?
If they were buying raw stuff and then cooked it properly and the environment's not contaminated with Listeria, then I'd say there's very low likelihood that those ingredients would be causing the problem.
Right. But just because you went in there and swabbed the environment once, does it mean Listeria isn't in the environment?
Right.
Right. So you probably also go back and collect some more environmental swabs because, you know, if you have a hospital, they know they have a Listeria outbreak, they might have done some deep cleaning of that hospital kitchen before you came in. So it probably makes sense to come back and do some more environmentals too. Okay. All right. So that happened. Visited the hospital a third time, sampled ingredients and this finished salad, and they found the Listeria in the freshly made chicken salad and the diced celery used in its preparation. Okay. Is that what we call, and you will hear this word when you talk about outbreak investigation, is this a smoking gun? Yadi, what's a smoking gun?
This is like where you find the root cause that you can just put out.
Right. It's basically if you have a murder case and you have someone sitting there with a gun that still blows smoke out of it, you're like, yeah, you probably fired that shot because you have this gun in your hand that still has smoke coming out. Yeah. So this sort of like, yeah, this makes diced celery pretty close to the smoke gun. Would there be enough to say it's the celery, or do you think you would want to do more?
Who am I? A
you
lawyer
can be
representing one of the patients, or
you can be FDA. You are FDA.
Okay. Probably not. Probably want to sample some more celery at the least.
Okay. Sample which celery and where?
The diced celery at, I mean, definitely all of the hospitals. And then I might want to go look at the celery supplier.
Okay. So trace the celery back to supply chain is probably what you would do. Would you do anything with the celery isolate?
Didn't it say that the strain matched the one from the? Yeah, I mean they sequenced it.
Yeah, good point. Yes, thank you. Yeah. So they did sequence it. Yeah, missed that. Yes, they did sequence it, so it matched. So that's pretty close to smoking gun, right? So, but you still want to go back and do more of a root cause analysis. How did it get on the celery, right? So that will be the next step. Going back to the celery facility, it's diced, so it must go in some sort of processing operation of some sort of scale, right? We've talked in the first one about traceback, so we're going to try to find out. This is not a celery traceback scheme, but it sort of shows that we want to find a common processor. And in this case, not a common processor. We're just going to go back because we have the smoking gun with the celery. We're just going to, okay, who made that celery? That diced celery should have some plant identifier, and that's the processing plant that we're going to visit. When you go into the processing plant, what are you going to do in that processing facility?
Swabathon.
Swabathon. So you're going to collect environmental samples. What else would you do there?
Can also like look up for their manufacturing conditions other than swabathon too.
Yeah, so you're going to review the environment. You're going to do a review and audit of the facility, look at sanitation records. Would you do any other testing?
I think if we're trying to link the particular strain, maybe if we get something out of those two tests that we are doing, we can try to match up with whole genome sequencing with our organism of interest, and that way we can take out the places that we don't think that our sample could have originated from.
Right, so if you find multiple positives in multiple places, or in any way, we're going to do whole genome sequencing. What do you sample? Some of the raw celery coming in? Could it come in with the raw material when you're there?
Yeah, I was going to say that you could sample the raw celery, but in thinking about that, there's such a high likelihood that you're going to have Listeria on there if it's coming directly from the field that I feel like you'd have to do so much sequencing to even find a positive that matches on the strain level.
Right. Yeah, you're probably not going to get that much based on our experience. You know, it's like there's on the field level in these products, you find 1%, maybe even less, because it's common in the soil, but it's not that well transmitted from the soil to the celery necessarily. So I will probably go in, since you're in there already, at least collect some loads of raw material. Based on what the facts we have so far, do you think it's more likely the raw celery coming in, or you think it's more likely in the processing facility? And why?
I think like more likely it is in the processing, because when we are getting the raw celery, as you said, that there's very less likely chance of contamination, and also in the industry, in the processing facilities where they chop it up into smaller areas, so that increases the surface area where the contamination potential is high. And also there are multi-handling things. We're handling it at different levels with multiple persons and multiple conveyors, belts, and places. So that increases the chance of it getting contaminated at the industry more than I would say the farm level.
Anything else about the outbreak that makes us think processing facility? Those cases occurred over 7 months, right? 7 months, same fingerprint.
Oh, yeah. So, yeah, then it's more likely that it's harbored somewhere within the facility and
right.
growing very slowly and not mutating enough that they're separate strains.
Right. I mean, I don't know that much about celery production, and you would look at that. Are they getting the same celery from the same field over 7 months? Is that Listeria living in one field specifically? Well, less likely. They're probably going to get it from different areas. It could happen, right? You want to look at your supply chain, but that length of contamination that the same strain is found in product for 7 months probably would indicate, or would point me more towards the processing facility along with everything else. So I'd probably sample the raw material, but I would focus on the processing facility, which is exactly what they did. They found it in the processing facility, was distributed to all hospitals from one fresh cut processing plant. So there was that common link, Jonathan, that you were after a little bit. 19 out of 200 swabs are positive for Listeria. So for those of you going to go into industry jobs, that tells you when investigation like this happens, there's a lot of swabs collected. This is what industry calls swabathons, like equivalent to a marathon, just with swabs. Lots of swabs collected, 200 is not unusual. And they also retested finished product 7 out of 10 positives on the finished product. Interesting, the comment was 1 positive matched the outbreak strains. It indicates there's sort of a broader issue there. Okay.
Yeah, that's terrible. 70%.
Yeah, 70% is problematic. Let's say the least. So that was that. So what next? Do those findings confirm a common source? It's pretty good, right?
Yes. Yeah.
Okay. So whole genome sequencing, here are the data. So you see clinical isolates here. So this is sort of a phylogeny or family tree. You see the clinical isolates, you see the environmental swab. You presume that that one comes from the facility. There are multiple swabs here, more clinical cases, more swabs. And then here you can even see the cut celery isolate from FDA. So you can see this whole cluster. And typically, if we count off, we hope to find in this part of the family tree 10 clinical. So let's do that. 1 clinical, 2, 3, 4, 5, 6, 7, 8, 9. I either miscounted or one of them wasn't sequenced, but essentially, we didn't know that was exactly this case, but it's pretty clear cut based on the dates and the information. So you can see these were collected in 2010, and we got the clinicals, we got the environmental swabs. So more or less between whole genome sequencing and everything else, very much looks like what I would call sort of a slam dunk that it survived in the facility in this specific piece of equipment. So there's the rest of the investigation. This is I think looks like a 483. So that's would be the write-up from FDA on the investigation. And it talks about them observing, dismantling the dicer and placing food contact parts of the machine on the floor for cleaning. So that means they take apart the thing, they put it on the floor, etc. And that is a machine that's used to dice processed items such as celery, potatoes, carrots, onions, and jalapenos. So considerable problem. Only the machine diced celery tested positive, not the whole or hand cut celery. This is about as clear cut as it can get. Okay. So let's put yourself first in the eyes of this facility. This is your facility. You're the QA person, or you're the newly hired QA person because they fired the old one after this one. What do you do? What are you going to do with this information? So here's your facility, Listeria Outbreak. It's the dicer. What are you going to do to bring this facility back up and running?
I guess before that, wouldn't the FDA shut them down?
Yeah, they will shut them down, but you have to, reopen it up.
We're shut down and we have to reopen.
Yep, exactly.
Okay.
So what are you going to do?
I would definitely sanitize the slicer. I would rewrite practices so that people know how to disassemble equipment. That's possibly more important than just sanitizing the slicer.
Right.
Employee training again.
Right. And then what else are you going to do when you start up?
I think I'll put in a sampling regime after the sample comes out of the slicer for future references.
Yeah. So most times you're going to have to start up. Most plants, practically speaking, they will start up not making diced celery or diced anything for a while. So initially they're just going to start up on whole product, lower risk product. That will be stage 1. Stage 2 is exactly what Jonathan said. Protocols in place, everything. Maybe toss out the dicer and just buy a new dicer just for good measurement. You could, improve the cleaning practices if it is cleanable. Often you might detect that it's not cleanable, and put in the procedures. And then in startup, you're going to do extensive environmental sampling, and you do what we would call test and release. So every batch of celery every batch of celery, carrots, jalapenos, doesn't matter what comes of the dicer. You're going to test probably 60 samples. And do a hold and release. So only if those are negative does the product ship. Okay. But yeah, you're going to focus on improving your environmental practices. This is common. Number of listeriosis outbreaks have been linked to persistent listeria contamination. It's well shown that listeria can survive in processing facilities and specific equipment over time, years and decades. Often survival is linked to what we call niches, areas where listeria can hide and is protected from sanitizers. And to deal with this, improved sanitation, improved preventative maintenance. So fixing things as they degrade and develop into niches. Sanitary equipment design, make sure that the equipment can be easily cleaned is important. And we need to have data to show that this is working. And this is a lot more involved, but this gives you a high level of what the facility needs to do. This is what typical niches look like. In the produce industry, these brush beds are common. And you can see that these brush bristles on this sort of conveyor insert into rollers, very difficult to clean and sanitize. Any cracks like this in the floor, the listeria could be under here, protected from sanitizer. Tight metal to metal junctures like here, equipment like this, how are you going to effectively clean this? Anytime you have things bolted together, so many places in a food processing facility that are difficult to clean and sanitize, where you need to do breakdown or come up with better strategies or better design to make this equipment more cleanable. It's another example of, poor welding jobs, these tight junctures. So the more you can weld things together to be clean, remove or prevent or avoid hollow framework because listeria can hide in there. All of these things become important to prevent listeria in produce processing facilities and other facilities. That's a whole other big topic, but that's what we're looking for here, and that's how we go after this, and that's how we bring up a plant up and running, but more importantly, use this information to make sure our facility never gets in a situation like this. So that's our first case study. The second one, going to be a little bit more quicker, is hepatitis A. This is, again, a real study. You have a clinician that informs the Pennsylvania Department of Health that they had a larger number of people than usually with hepatitis A. Number of them report having gone to restaurant A. Inspectors dispatched this restaurant, no sanitary violations. So what that often means, people seem to be washing their hands, seem to be wearing gloves, seem to be, there's no raw chicken dripping on something else, not that it has anything to do with Hep A, but identified food workers who were ill, restaurant closes, a lot more cases come to light over time, and it's your classical Hep A outbreak linked to a single restaurant at this point. Okay, so a little bit about background about Hep A. Obviously, now we're moving from bacteria to viruses. It's a single-stranded, non-enveloped RNA virus. So non-enveloped RNA viruses are those viruses that survive environmental stresses, can survive through stomach. Not like COVID-19, which is an enveloped RNA virus, which is very susceptible to environmental stress. There's a vaccine available. Overall number of reported cases is actually pretty small, but there are going to be a lot of unreported cases. Don't confuse Hep A with Hep B and Hep C. Hep A is fecal-oral transmission. That means human-human contact, contaminated food or contaminated water, while hepatitis B and hepatitis C are blood-borne pathogens. And, reported outbreaks for Hep A, support typical person-to-person transmission. You can see, contact of child employee, international travel that can be linked to food and water often, etc. So, unlike Listeria, where we talked about it can grow in a food if you store it, viruses don't grow outside a host. So it is what it is. Once you contaminate it, it doesn't become more. It only can sort of slowly die off. So here are the timelines of events. Confirmed Hep A outbreak that is associated with restaurant A. Restaurant A says, yeah, based on the data, was probably us. We have employees that are sick. They're shut down, at least temporarily. And this is the outbreak, what we call a classical epidemiological curve. You see the first case occurred on October 15th, then some more on the 17th, 19th, and so on. And you have two different colors in this graph, and this is important. So gray is the patrons, so the people went there, and these brown or yellowish brown looking one, that's when you have employee cases. And then it went back down. The number of cases, partially probably because the restaurant closed, and this is what we have. So what are the next, similar question to before. So this is our outbreak. Your restaurant is somewhere here. Are you ready to reopen? What are you gonna do? And what do you need to put in place? Any questions? What would you do?
What was the question again?
Restaurant was closed after the outbreak. Here's the epi curve. Here's the data. You're the restaurant owner. Are you going to open again? What are you going to do? And if you open again, what are you going to do anything different? Are you going to make any changes?
I think if we are opening back up, maybe proper employee hand sanitation and proper practices for manufacturing would be something that put in place, and then regular checkup, because as said, like this is how it is transmitted through fecal matter. So that means like not enough bathroom practices are being followed in that restaurant. So that is something to look forward to in the future.
What other policies would you enforce, Jonathan? So hand washing, particular hand washing after toilet use. What else?
Just like general employee health check type of stuff, like, not so much do you have jaundice, etc., but just, are you feeling well today? That type of a question.
So reinforce sick policies, right? If you're sick, don't come to work. This is obviously one of the challenges, right? Throughout the food industry, it almost doesn't matter whether we're talking about harvest workers, whether we're talking about restaurant employees. If they don't have paid sick leave and they need that job to put food on the table, there's a risk that sometimes people will come to work when they're sick, when they're mildly sick, because they convince themselves it's not that bad, right? And it's the eternal issue, essentially. So trying to reinforce that, in a perfect world, of course, you're going to offer paid sick leave, right? So that people actually are not motivated to come in. And this can take this can be more complex too, right? And we've seen this with COVID-19. It's not just, even if you have paid sick leave, but then we give you an attendance bonus, saying, well, if you have perfect attendance record for 60 days, you get a $600 bonus. It's day 58. You've been there for the last 58 days. You have a little bit of diarrhea. You're like, $600, do I go in? Do I lose my record? You're gonna wanna have that perfect record because you're gonna get a $600 check. So really need to rethink your employee leave position. So, okay, so we said, let's do this and let's reopen. Well, you reopen, but in the meantime, the state health department, I'm making this up a little bit, is finishing their case control study, where they're looking at the patients, controls of people that are not sick, and they interview them. Have you guys seen case control study data like this? Have you looked at those? Do you know how to interpret these?
I think so. Not in a while.
So take a look at those. What does this one tell you? And let's just focus on menu items consumed first.
Like your question is, what is the odds ratio?
Right. What does this tell you? You're the restaurant owner. You see this. You're like, ooh. Not that this is really how it's going to happen, right? The health department is going to say, yeah, you're going to just looking at your employees isn't going to be enough because what we see here. But let's say this were you and you see this as a restaurant owner or as a local health department. These are the results you get from your case control study. What is that telling you?
It's the odds that a certain food item is directly associated with the pathogen of question.
Let's make it more specific. I mean, we got food items here, right? We got mild salsa, grilled chicken fajitas, bar beverage, ground beef burrito, etc. And then we have some odds ratio numbers here. What does this specifically for this outbreak? This is for this outbreak. What does it tell you for this outbreak?
So just looking at this table, mostly the cooked food had less number of patients assigned, whereas like mild salsa, and if we look at the ingredients that go in, so we can easily relate that it came from raw ingredient, and then because there was no cook step in the mild salsa, I think it just stayed in there. So we need to look into that part of our restaurant more clearly for next time.
Right. So you just started your restaurant 3 days ago, started paying everyone sick leave. You know, you're like, I got this under control. And now you see this. What are you going to do? Are your improved sick leave policies going to control this issue?
Possibly not.
Probably not, because this odds ratio of 20 means people who got Hep A were 20. If you consume mild salsa, you were 20 times more likely to get Hep A. That means it's coming from the mild salsa, most likely, and it probably coming from specific ingredients. In this case, it seemed like the diced white onions were actually not ingredients. The green onions were the main ingredient. So it's actually not an employee issue. Yeah, you had sick employees, right? But the sick employees didn't cause it. What happened instead?
Some sort of supplier.
Right. And the
issue.
employees probably ate the product. And that's why the employees get sick, because, you know, they're in the restaurant, they're going to eat some of the food there before they go home. So if what the employees weren't the cause, the employees were the effect, right? And you jumped on the sort of immediate conclusion must be the employees, because often it is. In this case, it was not. It was supply chain. It came in with the raw material, most likely, came in with probably the green onions, and it could have been missed, okay?
I just have like one question on that table. So like we still cannot take employees out of the equation, right? So if one of the employee who has Hep A and he is prepping with the green onions, and those green onions go with like into the mild salsa, so he might be the source that led to the preparation of that particular recipe. And like in most
really good point, Yadi. That's right. I mean, if you say, well, Martin, you know, what if it was employee A who was only job was to make the mild salsa, and he or she contaminated the mild salsa? But it all then boils down to the green onions, the ingredients, where the ingredients tested from a closed bag, right? And this is very important in this outbreak investigation. If you obtain a pathogen, well, in this case, it was not a pathogen, it was the odds ratio. The association with green onion could still be that employee handled green onion. So you're absolutely right. The other thing is, you know, real life is more complex. It is also, we can't exclude a role of the employees. Maybe it came in with the green onions into the mild salsa. People got sick, some employees got sick, but then the sick employees would still come to work and continue the outbreak and make it worse, right? Absolutely. And this is, we're getting at the right point here, really to understand, saying, you know, often we look at black and white, employees or salsa. Well, sometimes it's a little bit of both. And then the question is, what's the root cause? And to a certain extent, even that's debatable. You know, your supplier of the green onions could be, but, you know, improper employee training, employees not staying home sick could be a contributing factor, one that made the outbreak worse. So all the right questions, all the right comments here. So this takes us and in this case, you know, FDA, based on this, and I don't know, we probably would have done some testing for hepatitis in the green onions. Virus testing on these sort of raw commodities is not easy, but you can do it. Another restaurant ended up also having an outbreak. So yeah, it's traced to multiple restaurants. So to make this sort of a long story, then we go back similar to the Listeria outbreak. We say, okay, it's onions, different restaurants, just like different hospitals. You see the commonality, common supply chain. Trace it back to farms in Mexico that supplied onions to all these restaurants as a course. So in this case, it was, the root cause was probably coming in with the raw material. And the problem with either contaminated water or sick employees, in this case, maybe harvesting or handling the product, probably happened at harvest, not at the restaurant. Next steps, restaurant chain. With this information, what are you going to do as your restaurant chain? Let's assume it was just one restaurant, but that restaurant was part of a chain. What do you need to do as a restaurant chain? What is this teaching you?
Reevaluate your supplier verification programs. Maybe identify, quote, high-risk ingredients that possibly change, or specify where exactly you want those coming from and what kind of practices you want.
Right.
You
got it. So that's
in.
so as a restaurant chain, you can't just buy some green onions. You need from somewhere on the market. You do want to know where they come from. You got to have some assurance. You got to have some supplier verification program in place. Exactly. And the FDA is probably gonna at some point come up with something like the foreign supplier assurance program, like they did with FSMA, and I'm sure I butchered the actual name of it. So that's what happens. And the compilation of multiple outbreaks in cases like that then lead to new regulation, as well as lead to industry as taking certain practices such as supplier assurance more serious.
I have a question. Would FDA today release a don't eat green onions based on data from one restaurant outbreak?
Well, I doubt it was just the one restaurant. I think there was probably more evidence from other ones.
Okay.
And they probably had some idea that similar issues may have happened in another one, but it can. I mean, we could argue whether that, some of the warnings for don't consume romaine weren't similar. And we've had, in the past, FDA sometimes has used those advices that don't consume raspberries from Mexico. And then it's like, oops, sorry, that wasn't what it was. So these things, I think that we will continue to see them. It depends on the severity of the outbreak, the scope of the outbreak. And to a certain extent, once the rumors are around that people know, it comes into the press, at some point FDA needs to say something in terms of the source. So this is a tough one. I sometimes would not want to be FDA to make that decision. When do you, release some of this information? And it's different things too. They can say, don't eat green onions, or say, we're investigating a hepatitis A outbreak where 90% of the patients with an odds ratio of 20 say they consumed green onions, right? It doesn't say don't eat green onions. It just says, if you know epidemiology and know what an odds ratio is, don't eat green onions, right? And in reality, if you look at what FDA posts today, they're getting better about transparency in their outbreak investigation. They often say, we have an outbreak of 20 E. coli 0157 cases, and patients, there's significant association with 2 or 3 different products, romaine and something and something. They don't say don't eat romaine, but some of us might look at say, based on this, I might just hold off on this product for a little bit. So these are some very complex questions. So, okay, so this is what we had for today. Thanks, Jonathan. Thanks, Yadi, for the contribution to this. I had fun. I hope you had too. Thank you.